Alright, hey everyone. I'll tell you what we're talking about sine rule. We'll look at ambiguous sine rule as well, looking at the whole idea that if we were to have a triangle that is not a right angle triangle, that we could use this rule to solve for unknown sides and angles, right? So, looking at what we have here, we have three angles in a triangle, obviously, which we'll call A, B, and C. Right? That's A, B, C. And we also have the side that is opposite those angles, which is called the corresponding side. So capital A, meaning the side opposite A, capital B, the side opposite B, and capital C, the side directly opposite C. Right? Now, the rule for sine rule is that, sine of A divided by A would equal the same thing as sine of B divided by B, which would equal the same thing as sine of C divided by C. So any combination of those three you can use to solve for unknown sides and angles. So let's say we have this triangle here. We have, in here we have 100 degrees. And we have 38 meters. I'm just making these values up. And let's say we have this one here. We have 38 degrees, no, I'm using 38 again, 36 degrees, and we'll have 20 meters, right? Now, actually that was a bad example. Let's scrap the 20 meters. We'll call this X. We'll find out what this is. This is an unknown side, right? So, forget the 20 meters, just work with that. So we'll have, so sine A, and you can decide which one is A, B, and C, by the way. You could say this is A, or that's A, or whatever you want. But so sine of 100 over 38 is equal to sine of 36 over X. And we want to find out what that X is. Now, one of the good things about sine rule is you can actually flip these fractions and not change the result. So we can do 38 over sine 100 is equal to X over sine 36. Alright? So that's good. It means that we can multiply both sides by sine 36. Which would just equal X, because that would cancel that out. Yeah, so I can dump this into my CAS. So let me just turn that on. And I have 38 over sine 100 times sine 36. Oops, sine 36. I'm going to get the approximate answer, which is 22.6804. I was pretty close with my guess of 20.68 meters. Okay, easy. Now, similarly, you can do finding for an unknown angle. All right, so now let me jump back over here and turn off my display for a second. Let's say I wanted to know an unknown angle, and I had the two sides. So I have 25 centimeters, I have 40 centimeters, I have so I have an angle of 50 degrees, and this time, just to make it challenging, I'm going to go a angle of let's say 35 degrees. So somebody in the other room is distracting me. Alright, okay, so let's say we got something like that. Now you might be looking at, like, I need either this angle for sine rule. Well, luckily, remember, the three angles add up to 180 degrees, which means if that's 85, that this must be 95 degrees, right? I think that's right. Okay. Okay. So, and I've stuffed up again. This is what happens when I get distracted very easily. All right, let's go to a new page. I want to find an unknown angle. I don't want to give you all the angles at the start. Okay, let's try that again. All right, triangle. We have the sides of what was it, 40 and 25, and we only have one angle in here, which is 50 degrees. All right, so we're gonna go with that. Okay, so let's use sine rule. So we want to find this unknown side in here, which we'll call B. So we got sine 50 over 25 is equal to sine B over 40. Okay. Now we multiply the 40 to both sides. We get sine 50 over 25 times 40 is equal to sine B. And then we do the inverse sine of that, of this whole thing. Right? And that whole thing should give me the value of B. So let's give that a go. Alright, next line. So we have, I don't know how to do inverse sine on the keyboard. So I have to go into here, inverse sine, and we have sine 50 divided by 25. Oh, not there. Sine 50 divided by 25 times 40. Undefined. Love that. Why is that undefined is the question. Domain error. Okay. That's an interesting one. Alright, I've never had that happen before. Alright, let's just try sine 50 over 25 times 40. Far out. Alright, and then let's try the inverse sine of this answer. Don't know why it's being so fussy. Alright, inverse sine of that is undefined. That's interesting. I've not seen that happen before. Maybe the triangle is not possible for some reason. Interesting. Alright, well, I'm not sure whether I'm not sure why that's happening. Unless I'm on radians. Oh goodness, this is so like. Degrees. Okay. For some reason, this one is not possible. It's really weird. Okay, let me just try another one. Just not sure what the go is with that. Weird. Alright, anyway, let's try another one. And let me turn off my display. I'm not sure what the go is with that one, but anyway. Okay. So, alright, anyway. let's try something like that. Hopefully this one works. So I have sine 40 over 35 is equal to sine b over 50 times 50 to both sides. Let's see what this does. Hopefully it doesn't stuff up like the last one. Sine 40 over 35 times 50. Okay. And then I need to do inverse sine, which is, I don't know why I did that menu because it's trig. Inverse sine, our answer. Yeah, there we go, that one's fine. So that one gives me 66.67 meters. Still a bit unsure what happened with that last one. Yeah, weird. Anyway, but this one works, so that's the good news. I guess that other triangle is just impossible somehow. Okay, so that's that. Now, you might be wondering, or you might get a situation where you get what's called an ambiguous sine rule question, where you get told that you get told that you have an angle. Let me get off display capture. All right, so you get told that you have an angle that is less than that is an acute angle. So let's say 20 degrees, right? And that the side opposite that, so capital A, is let's say let's say 80 meters, right? So we got that, and we'll also have the adjacent side, so another side that is let's say is like 60 meters. All right, so I've got this angle in here, A. Just going to make sure that I've got that right in terms of the details required. I think this one has to be bigger. I might have stuffed that up, sorry. Let's make this one 120. All right. We have angle A in here, and we have our side B as well. Let me redraw this. So let's do angle A in here is 20 degrees. All right. So we have that. We have our 120 meters here. Right. We have some unknown angle here, and then this one's our 80. All right. So in a situation like this, well, let me scooch that up. We can do our sine rule as normal. So we have some unknown angle in here and 120. We have 20 and 80. Okay, so sine rule, we have sine of 20 over 80 is equal to sine of the unknown is equal to 120. Okay. Right. So we multiply the 120 across, we get sine 20 over 80 times 120. Let's try that. So we have sine 20 over 80 times 120. Alright, so it gives us that. And we do an inverse sine on our answer, and that gives us our other angle to be 30.9 degrees. Now I'm just gonna have to flip this for a second. So we have a situation where we have our triangle that's 20, right? And this is, what was this, 30.9. Alright, which means that our angle at the top is a big one. That means it's like what would that be? 50.9 away from 180 is like 129.1. Something like that. Alright. Then we have the 80 and the 120, and then this is some big length here. Okay. So that's what our answer can look like, but there is a situation because of the way that the triangle was described to us may not necessarily be 100% accurate, right? So if we know that we have an angle 20 in here, right, and we have an opposite angle of 80, right? It may be that this angle here is the obtuse one, not the one at the top, if that makes sense. So there could be a situation where, I'll try and draw it properly, but essentially it's going to look like this. Where this is 20, right? This is 80. This is 120. Yeah. So in that situation there, right? Because they're the three values that we get. We get the opposite and the one that goes alongside it. But it doesn't necessarily specify that this whether this one's the hypotenuse or not. Okay. Now in this situation, it's not necessarily a disaster because this triangle actually fits perfectly with this triangle, right? They make a nice complete triangle. So I'm going to sort of draw that one there. And we draw the other one in here. Alright? And they actually make a proper triangle together as well. So with our 20 and 20, they make a, what is it called? Isosceles? Yeah, so that's something to consider. So those angles will add up to something, but this angle here is the important one, right? We're looking for another possible angle instead of 30.9. Okay, so in this case we're like, okay, that makes a straight line when we put the two triangles together, so I can just do 180 minus whatever I got as my original sine rule angle, and that would give me 129, 149. Oops. So right, 149.1 degrees, right? So you could say that this triangle is also this, right? And then that would leave this angle to be very, very small here. It'd be like 20 and like 10.9 or something. So there are two possible triangles to be made from the information that we got at the start. That's ambiguous sine rule. All you really need to know is you need to, I guess, find the unknown angle that you're looking for, and then draw, or then find whatever 180 minus that is, I guess, right? Hopefully you found this useful. Cheers, bye.